Hello, welcome back. Online school has been a blast, right? Alright, so today we're going to start talking about making sketches of higher degree polynomials. You can read through that. It says we should know how to graph degrees of 0, 1, and 2 fairly well, which is true. We should all be able to draw a horizontal line. Degrees 1 should be able to draw a linear equation. Remember, y equals mx plus b. And quadratics that are second degree. We've talked about how to get those into the graphing form and how to graph them in their standard form as well, or factored form. So, things that are higher than degree 2, we have to know a few things about how to make sketches, and we'll worry about more accurate graphs later on, but hopefully we can at least come up with some decent sketches. And we want to remember that a polynomial function is continuous. So I'll take a look at a couple pictures here. So notice in picture A, it is continuous. We don't have arrows on it, but there should be arrows there. Anytime you see a break in a graph like this, that means they cannot be expressed as a polynomial. Alright, another feature of them is that they all have like smooth curves. We can see this one. Things that are not polynomials have sharp turns. So you would say right now, Mr. Grossman, an absolute value function is not a polynomial. And I would say, amazing. Alright, so one of the things that we can learn about them is their end behavior. And this goes back to their degree. So we're going to call this the leading coefficient test and talk about the basics of it here. So notice here, this is when we have odd degree functions. This is what they look like. They shoot off in two different directions. So things like x to the third, 5th degree, 7th degree, this is how they all look. They always shoot off to negative infinity. Well, x to negative infinity is y goes to negative infinity. And notice they also go as x goes to infinity, y goes to infinity. So this is when you have a leading coefficient that is positive. So if there's a negative out in front of it, that would make it negative. So this is positively oriented. So like 5x squared is a positively oriented polynomial. So over here, if they had a negative out in front of them, notice how they've been flipped over. Okay? And again, their end behavior is what we're worried about. So as x goes to negative infinity, y is going up here, so y will go to infinity. And as x goes to positive infinity, notice y is going to negative infinity. So they're kind of flip-flopped on what their end behavior actually is. There we go. So when it is even, so when your degree is 2, 4, 6, 8, whatever, these are the patterns that follow. So if it's positively oriented, notice both ends open up. And you can think back to a quadratic. If it was positive out front, it opened up. If it was negative, it opened down. So notice as x goes to negative infinity here, y goes to infinity. And when we look over here on this end, as x goes to positive infinity, y goes to infinity. So notice the y values go in the same direction with even degree polynomials. And here we got them opening down. So this would be something with a negative out in front of it, like negative x to the 4th. And notice as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to negative infinity. So notice both sides, the y values are going down. So that's what we have to look for when we're trying to describe the end behavior using the leading coefficient test. Is it even or odd, and is it positively or negatively oriented? And then we can just look back here until we memorize it to write our answers out. So we'll take a look at these. I'm having a super hard time writing on this since I'm not at school, so we're going to try our best. But notice, we look at this. The degree of this guy is 3, and it's negatively oriented. Okay, so I'm going to draw a picture real quick. from that information, I know that graph looks something like that because it's odd degree and negatively oriented. But what we need to do here is be able to describe what's happening with its end behavior as well. So let's try to type. So I'm going to say as x goes to, I'm going to put positive INF. So positive infinity. I'm not sure how to make the negative infinity. This guy means that x is going, or y is going to negative infinity. Because as x gets bigger and bigger, this graph is going down. And then as far as I can go here. And then as x goes, goes to negative infinity, y goes to positive infinity. It's going to run into my other example here. So let's do the same thing. I'm just going to be really lazy and try the next one here. So notice this one is an even degree polynomial because it has a degree of 4 and it's positively oriented. So when we think about, a quick sketch of what it might look like, it's going to probably look something like this, like a W. Both ends be opening up. So let's fill this guy out. So when we think about x going to positive infinity, that means as x is getting bigger, so is y. So y is going to positive infinity. And as x goes to negative infinity, we got the same thing going on here, that y is going to go to positive infinity because both ends open up on an even degree polynomial. Alright, so let's try the third one. So the third one, look what do we got. Is it even or odd? It is odd. It's a 5th degree polynomial. And it is positively oriented, so we know it's going to look something like this. It might have a couple more humps in it because we could have up to 5 solutions, but we know it follows that general pattern. As x goes to negative infinity, y goes to negative infinity. As x goes to infinity, y goes to infinity. So, let me delete that guy. There we go. So we're going to have to fix this. So as x goes to infinity, y is going to infinity. And as x is going to negative infinity, so is y. So notice with an odd degree polynomial, it's positively oriented. They head in the same direction on both ends. Alright, so now here's just a picture of a nice accurate graph so you can kind of see what's going on here and see that as x goes to negative infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. So back here, as x goes to negative infinity, y goes to positive infinity. And as x goes to infinity, so does y. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. Man, I'm tired of saying infinity. Alright. So we also should be able to find the zeros. And here's some information you can read through. You remember zeros we've been typically finding through factoring to find where it crosses the x-axis. And we'll worry about the relative extrema and relative minima or maxima here in a little bit. So just want to point out that we talk about this stuff all the time in class, but sometimes I think it doesn't sink in that these are just different ways that we could state a root, a zero, a solution, an x-intercept. These are all the same thing. So when we're doing all these different things like factoring, that's what we're doing, is finding these zeros, solutions, roots, x-intercepts, whatever you want to call them. Alright, so if this guy here, what do you think we're going to do? Factor. So first thing we should do is say, what do they have in common? And again, can't write it all out. Because we say, oh, they all have an x in common. So you factor out that x. And now we just got to find two numbers that multiply together to give us -2 and add it to be -1. Nice easy factoring. So we've got this trinomial factor, this third degree polynomial, and now we should be able to graph it if we wanted to as well. I'm going to try to squeeze in just a quick sketch here, so I want to make sure we're understanding what we're doing. And this is probably going to turn out horrible. So there's our x-axis. There's our y-axis. So I'm going to say here is positive 1, here is positive 2, here is negative 1, because hopefully we see that's where our solutions are. So I'm crossing at 0, positive 2, and negative 1. And since I know it's a positively oriented third degree polynomial, I'm going to come up through here, come down through 0, and then I've got to cross back through here at 2. And again, we'll worry about more accurate ones. We worry about, you know, the relative max and mins there to really figure out how the heights are. But for right now, online here, I think this is good if we can master this. Alright, so here's another example. Notice this is a fourth degree polynomial that's negatively oriented. So you should be thinking, oh, both ends are going to be open and down on this if we graph it. So again, same thing. We got to factor it. So hopefully notice they all have a negative 2x squared in common, so we factor that out. And now we're left with x squared minus 1. And again, hopefully you see that x squared minus 1 is difference of squares, and that factor is the x minus 1, x plus 1. So again, now we have our solutions. So notice fourth degree polynomial. We got one solution here, and we have two here. They're just the same thing, both 0. So again, I'm going to try to make a sketch of this so we start thinking about all this. So now, oh, that was way straighter. That looks way better, all right? So now we have a root at 0, positive 1, and negative 1. So I'm going to spread them out a little bit. There's negative 1, there's positive 1. And since we know fourth degree negatively oriented, it's going to be opening down on both ends. So I'm going to cross through. This is going to take you back to algebra 2. So I have a root right there, but notice it has a square on it. And it crosses through positive 1. Remember, anything that has a square, anything even degree, it hits the x-axis and bounces back off in the same direction that it came from. Alright, so this kind of gets into what I was just talking about, the multiplicity. So anything with an even multiplicity hits the x-axis and bounces back off like we just saw. Anything with an odd multiplicity, say that's just the x-axis there, what it's going to do is it's going to come up and wiggle through the x-axis. Not the best example, but that's what it looks like. You know, think about graphing y equals x cubed. You can see it do that wiggle through the origin. Alright, so we got an example here, and you know, if we're not sure what to do with them, like factor or you know, have some other method of solving, what we're going to need to do is put it in the calculator. And I know you guys don't have a calculator there, but notice we can see that graph right there, and it follows all the rules. It's an odd degree, positively oriented polynomial. We can see it's in behavior, follows the rules. But notice it only crosses, it looks like 3 times. So what we're going to have to assume there is, since it's a 5th degree polynomial and it only crosses 3 times, that there are 2 imaginary or complex solutions, because we should always have enough solutions as our same number of solutions as our degree. And we can see it right there. If we solved x squared plus 1, what we would get, we'd have x squared plus 1 equals 0, subtract 1 and take square root, we would have x equals positive and negative I. So there would be the 2 complex solutions that we can account for. So now we have all 5 solutions. So hopefully you see how all this stuff is kind of going to play together that we've been working on. Alright, so next thing is you need to be able to write polynomials if you're given the roots. So I'm just going to kind of walk you through this because it's really not that hard. So here's the first example. if we have a root at positive 3 and positive 3, we'll start with that one first. You think about it in factored form. X minus 3, because a positive 3 makes it 0, and since there's two of them, we have to put a square on it. Now the negative 1/2, we talk about how we can quickly solve stuff. I always tell you, like, want to quickly solve it, it's the opposite of the number by itself over the number by the variable. So you just kind of work backwards in that same idea. The opposite of number on top, positive 1, over the number by the variable, that's the one that was by x, right? So that's an easy way to rewrite these. And as far as these go for online, I'm not going to worry about them because I think it'll cause a lot of confusion. But with integers and simple rational expressions, I think we should be able to do this. And then you can multiply it out using the box method and make it look really confusing, because now you can't see what the roots are or anything, but that is something we're going to be practicing. Alright, so it's all about sketching. Hopefully you're looking at this going, I know Mr. Grossman's going to say we need to factor it. And do the leading coefficient test and all that fun stuff. So we know this is an even degree polynomial and it's positively oriented, so both ends open up. And let's go through. If you factor this, they didn't give the example of the factoring. Well, here they have what? 3. No, I'm screwing this up already. So they have an x cubed in common. So that's an x cubed. So we factor that out. Now we're left with 3x minus 4. Alright, so to graph this, we've accounted for our 4 solutions. We got 3 right here and 1 right here. It has a triple root at 0, and we have a single root here at positive 4 over 3. We'll scroll the graph down a little bit. And the one on the left here is just showing the basic shape of it, because that's what we know. So notice we just come down through here, put a little wiggle, because that's a cube root, and then we have to come back up right through 4/3, and we have our graph. And again, we'll worry about finding these high and low values a little later. Let's just focus on getting the sketches done. Oh, I just realized you couldn't see that. So I'm down, there's our triple root 0, and up at 4/3. Alright, so let's do another one. So this is a little bit trickier because it's got that fraction in it, but we've kind of talked about this as well. So we could factor out a half out of all this to get rid of that fraction. That'll make life a lot easier, because now notice, with the x as well, we can use our box method to factor 4x squared minus 12x plus 9, and it factors the 2x minus 3 times 2x minus 3. So now we can see a single root at 0 and a double root at positive 3/2. So this was an odd degree polynomial with negative, so we know it's going to look something like this. So let's scroll down and see what we got here. There we go. You can't see everything now, but we can see most of it. So again, we know that general shape that I sketched up here. We have a single root 0 and a double root at positive 3/2. And since it's negatively oriented, we start up here and cut through those points. And again, we'll worry about these, how to get these points more accurate later. We want to just be able to get the general shape right now. And please message me questions, any issues you might be having. I'm trying to make sure I have all the work up for the whole week, and that way you can look through it and make sure you're going to have time to ask me questions. Anytime during school hours I should be available, other than if I'm eating lunch. Alright, hope everybody's staying healthy.